want to find the inverse Laplace transform of 2s squared plus 10s over s squared minus 2s plus 5 times s plus 1. The first step is going to be to deal with this s squared minus 2s plus 5. This cannot be factored, so quadratics that cannot be factored, as we've done in previous videos, need to be written as s minus a squared plus b squared. Multiplying out that right-hand side gives me s squared minus 2as plus a squared plus b squared. The coefficient of s on the left-hand side is negative 2. On the right-hand side is negative 2a, so in this case a is equal to 1. The constant on the left is 5, and on the right-hand side is a squared plus b squared. We already know that a is 1, so we have that b squared is equal to 4, or b is equal to 2. So with that, I'm going to rewrite this problem as the inverse transform of 2s squared plus 10s over s minus 1 squared plus 2 squared times s plus 1. And we still have a little more work to do. We now need to actually break this up using partial fractions. So when we do this, I'm going to take this fraction, 2s squared plus 10s over s minus 1 squared plus 2 squared times s plus 1. On our table, things with the denominator of this form, s minus 1 squared plus 2 squared, or s minus a squared plus b squared, have two possible things in the numerator. The s minus 1, so we can have some multiple of that, or with the same denominator, we could have a b on the top, so in this case a 2. And then we're going to have a multiple of that. We also had a linear term on the denominator here, so we need to include a linear term on the right-hand side as well. So let's multiply this by our denominator. S minus 1 squared plus 4 times s plus 1. When we do, we get 2s squared plus 10s is equal to a times s minus 1s plus 1 plus 2b times s plus 1 plus c times s minus 1 squared plus 4. And so now we just need to solve this. I'm going to start by letting s be equal to negative 1. That gives me, on the left-hand side, 2 minus 10. On the right-hand side, this a term will go to 0 and the b term will go to 0. I would have c times negative 1 minus 1 is negative 2 squared plus 4. This would then simplify to negative 8 equal to 8c. So we have that c is negative 1. Unfortunately, there's not any other nice numbers that I can stick in to make two of these three terms go to 0. So from here, I'm going to expand this out. 2s squared plus 10s equal to a s squared minus a plus 2bs plus 2b plus cs squared minus 2cs plus 5c. And now we can start looking at coefficients. Here is an s squared term, and then here and here. So we have 2 is equal to a plus c. We already know that c is negative 1. So that tells me a is equal to 3. Looking at the coefficients of s, I have a 10s, 2bs minus 2cs. So we would have 10 equal to 2b minus 2c. I already know what c is, so this is 10 equal to 2b plus 2. That tells me 8 is equal to 2b, or b is equal to 4. So with that, I can rewrite this problem. We had the inverse Laplace transform of a times s minus 1 over s minus 1 squared plus 2 squared plus b times 2 over s minus 1 squared plus 2 squared plus c over s plus 1. So now we need to transform this. Our table tells us that the transform of e to the at cosine bt is of the form s minus a over s minus a squared plus b squared. So this first term would be 3 times e to the, in this case a is 1, so we have e to the t, cosine 2t, since b would be equal to 2. It also gives us the transform of e to the at sine bt is of the form b over s minus a squared plus b squared. So this would be plus 4 e to the t sine 2t, since a is 1 and b is 2. And finally, the transform of e to the at is 1 over s minus a. So you would have minus e to the negative t, since here a would be negative 1. So now I have my solution.